Hi kids, in this video we'll continue with motions in one dimension, class 9 physics, and we will look at numericals from exercise 2b from Concise physics, which is totally based on graph. Let us look at the first sum. Shows the displacement time graph for the motion of a body. Use it to calculate the velocity of the body at 1 second, velocity at 2 seconds, and velocity at 3 seconds. And then draw the velocity time graph for it in this figure. Very easy. If you look carefully, the displacement time graph is a straight line inclined to the time axis at a certain angle, which means this is a case of uniform velocity. The body covers equal distance in equal time interval. Over here 2 meters for each second. Now, velocity at 1 second. Displacement is 2 meters, so 2 meter by 1 second, that's 2 meter per second. Velocity at 2 seconds, in this case the displacement is 4 meter, time is 2 seconds, that's 2 meter per second. Again 3 means over here 6 meter by 3 seconds. See, velocity at 3 seconds, displacement was 6 meter, so that's 2 meter per second. See, the body is moving with uniform velocity, covers equal distance in equal interval of time. Now they told us to draw the velocity time graph. Very easy. After 1 second, the velocity was 2 meter per second. After 2 seconds, again it was 2 meter per second. After 3, it was again 2 meter per second, which means we'll get a straight line parallel to the time axis, isn't it? So this is your graph, velocity time graph for this displacement time graph. Clear? Now let us look at the next sum. Now look at sum number 2. Following table gives the displacement of the car at a different instant of time. Jot the displacement time sketch and find the average velocity of the car. The first part we'll do first. See, draw the graph. Let us see. This is suppose displacement and this is your time. 0, 1, 2, 3, 4, 5. This is time in second. This is displacement in meter. 5, 10, this is 15, 20, 25. Now after 1 second, the displacement was 5. So over here, see, after 1 second, the displacement is 5. If you do it in the graph, you'll get a perfect one, okay? After 2 seconds, it's 10. So somewhere over here. After 3 seconds is 15, which means somewhere over here if you look carefully. After 4 seconds is 20, so it covers equal distance in equal interval of time. So we'll just join this. Yeah, you'll get a straight line. See, you have not joined it properly. Yeah, you'll get a straight line. Done. Now what they have asked. First part is done. Find the average velocity of the car. Average velocity, see. Average velocity. Total displacement of the car is from 0 to 20. That's 20 meter. And total time taken is 4 seconds. So that's 5 meter per second. That's the average velocity. Now, in part B, what they have told us, what will be the displacement of the car at 2.5 seconds? So, at 2.5 seconds, somewhat over here, 2.5 seconds. What is the displacement? So, we'll draw a vertical line. As soon as it touches the graph, draw a horizontal line on the y-axis. See, it's coming in between 10 and 15, which means displacement after 2.5 second is 12.5 meter. Then they have asked displacement after 4.5 second. Again 4.5 is over here, isn't it? So we'll draw a vertical line, and the point where that vertical line meets the graph, draw a horizontal line. Okay, see, it's coming between 20 and 25, which means 22.5 meter. That's your displacement. Done. Now let us look at the next one. Now look at number 3. A body is moving in a straight line and its displacement at various instant of time is given by the following table. Time was 0 second, the displacement was 2 meter. When the time was 1 second, the displacement was 6 meter. Like this, they've given the table. You can see in this question. Plot displacement time graph and calculate. There are two parts. I'll first plot the displacement time graph. Look over here. Just be careful. This is your displacement in meter, and the horizontal axis is time in second. 7 seconds. So 1, 2, the distance should be same, okay? 3, 4, 5, 6, 7, 8. You can do it in the graph, okay? It will be better. The maximum distance is displacement is 24. So what I'll take, look over here. Suppose this is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay? Now we need to plot it. Just look over here. When it was 0, this is 0, the body was over here. 2. After 1 second it was 6. So somewhere over here. After 2 seconds it was 12. So somewhere over here. After 3 seconds again it was 12 only. Over here. Okay. After 4 seconds again it was 12. Over here only. Then after 5 seconds it was 18. 18 is over here. So after 5 seconds the body was over here. After 6 seconds is 22. So somewhere over here 22. After 6 seconds over here 22. And after 7 seconds it was 24 over here. Look carefully. So this is my 24. Now let us join the points. If you look carefully, this straight line, now I think, yeah, this is clear. Now what they've asked, this is done. Your graph is done. Then they have asked, what will be the displacement? Sorry, I was reading number 2. Plot displacement time graph, done. Calculate the total distance traveled in interval 1 second to 5 seconds. From 1 second to 5 seconds, the total distance traveled. Now, at 1 second, the displacement was 6. Displacement after 1 second was 6 meter. And displacement after 5 seconds. Displacement after 5 seconds was 18 meter. So the distance traveled will be the difference of these two. 18 minus 6, that's 12 meter. That will be the distance traveled during this time interval. Okay, because it started with 6 meter. Now, average velocity of in time interval 1 second to 5 second. Over here, average velocity. So, average velocity in that time interval 1 second to 5 second. Look over here. Displacement of the body was 1 second was 6 and 5 second was 18. So displacement will be 18 minus 6. Time was what? 5 minus 1. Average velocity is what? Total displacement by total time. So this is 12 by 4. That's 3 meter per second. That's the average velocity in time interval 1 second to 5 second. Clear? Now let us look at the next one. Now look at sum number 4. This figure shows the displacement of the body at different time interval. Calculate the velocity of the body as it moves for time interval velocity from 0 to 5 second, from 5 second to 7 second, and the velocity from 7 second to 9 second. Again I'll read. Calculate the velocity of the body as it moves from 0 to 5 second, 5 to 7 and 7 to 9 second. Just the first part. Let us see over here. From 0 to 5, if you look carefully, the displacement is 3, isn't it? So 3 by 5, that's 0.6 meter per second. Now from 5 to 7, this interval, at 5 second the position of the body was 3 meter, the displacement. At 7 second also the displacement was 3 meter, which means there was no displacement at all. The total displacement is 0, because 3 minus 3 will be 0. Over here it was 3 minus 0, which was 3. But in this case, from this time interval, see, the body is at rest, which means displacement will be 0 by 2. This is 0 meter per second. Then they have asked for 7 to 9. Now 7 to 9, again if you see, at 7 second the displacement was 3, at 9 second it was 7 meter, which means the displacement will be 7 minus 3. This will be the displacement during this time interval, isn't it? Look carefully. At 7 second the body was at 3, at 9 second the body was at 7. So the difference of these two will give you the displacement. By time is what? 9 minus 7 is 2. That's 4 by 2. That's 2 meter per second. Done. The first part. Calculate. Number A was this. Number B. Calculate the average velocity during the time interval 5 to 9 seconds. Now from 5 to 9 seconds, they have asked for average velocity from here to here. Now average velocity from 5 to 9 seconds, this interval. Now at 5 seconds the body was at 3 meter. At 9 seconds it was at 7 meter. So the total displacement is 7 minus 3. 7 minus 3. And time is what? 9 minus 5. That's 4 by 4. That's 1 meter per second. That's your average velocity. Done. Now let's look at the next one. Now look at number 5. From the displacement time graph of a cyclist given in this figure, find the average velocity in first 4 seconds. First 4 seconds. Just look over here, which means from here to here. Change in time is 4 minus 0. And displacement 0. And at 4 seconds it is, look carefully, 10 meter. So that's 10 minus 0. 10 by 4 is what? 2.5 meter per second. Clear? Very easy. Number 2. The displacement from the initial position at the end of 10 seconds. So at the end of 10 seconds, if you see, the displacement of the body is at minus 10. Displacement can be negative based on the direction. So displacement is minus 10 meter. Done. Number 3. The time after which he reaches the starting point. Now the starting point is this. There are 2 instants when it reaches the initial position. After 7 seconds and after 13 seconds. Isn't it? At these 2 time interval, he reaches the starting point. If you look at the diagram carefully. Now let us look at the next one. Now look at sum number 6. Figure this represent the displacement time sketch of a motion of 2 cars A and B. Find number 1. The distance by which the car B was initially ahead of car A. This is your car B. It started with 40 km and the car A is at the initial point only, which is 0. So the car B is ahead of car A by how much? By 40 km. So that is your first answer. Now number 2. The velocity of car A and car B. For the car A, see, it's a straight line inclined to the time axis at a certain angle. So it is uniform velocity. So I'm taking 2 intervals. Suppose 0 and 2. These 2 intervals. You can take 0 and 4 also, your wish. You know. So velocity of A. Change in y coordinate. This is displacement. 80 minus 0. The slope, displacement time graph, the slope gives us the velocity. Change in y coordinate, this is 80 minus 0. Change in x coordinate, which is 2 minus 0. That's 80 by 2, 40 meter per second. Or somebody can have taken 0 to 4. So at 4 hour, it was 160 kilometer. So 160 minus 0, that's 160. 4 minus 0 is 4. So 160 by 4. Again will be 40 meter per second for the body B. And again take 2 intervals. Suppose I take 2 second and 4 second. Again that's a straight line. Again see, inclined to an x-axis at certain angle, because if you proceed it, you know, it will meet the x-axis at certain angle. So I take these 2 points. So at 2, the displacement was 80 kilometer. At 4, it was 120 kilometers. So change in y coordinate is what? 120 by 80. That's 120 minus 80, sorry. Change in x coordinate is 4 minus 2. That's 40 by 2. That's 20 meter per second. That's the velocity. Sorry, that's in kilometer per hour. Extremely sorry. Yeah, kilometer per hour. Now look, number 3. The time in which car A catches car B. So after, I think, 2 hours, both are at the same point. After 2 hours. Number 4. The distance from start when the car A will catch the car B. So at this instant, which means at 80 kilometer, you know, your car A will catch the car B. Is it clear? Now let us look at the next sum. Now look at number 7. A body at rest is made to fall from the top of a tower. Its displacement at different instant is given in the following table. For example, 0.1 second, the displacement was 0.05 meter. After 0.2 second, the displacement was 0.20 meter, like so on. Draw the displacement time graph and state whether the motion is uniform or non-uniform. Very easy. If it's a uniform motion, we'll get a straight line inclined to the time axis at certain angle. Okay, and if it's a non-uniform motion, we'll get a curved line. This is displacement in meter. This is time in second. I've drawn this 0.1 second, 0.2 second, like this. And this, your displacement is 0.5 5 meter, 1 meter, 1.5, 2.0 meter. Now look carefully. Which means I've divided this portion into 5 equal parts. And each part is equal to 0.1. 0.1 second. The displacement is 0.05. So 0.1 is over here. Somewhere over here. Look carefully. This is your 0.05 meter. 0.2. See, this was 0.1. This is 0.2. Somewhere over here. Isn't it? 0.3 second. The displacement is 0.45. 4 is here. Sorry, 4 is here. 1, 2, 3, 4. 0.4. This is 0.5. Somewhere in between this. Which means, I told you if you take a graph now, this will be clear. The point will be precise, you know. Then 0.80. 0.80. See, 0.5, 0.8. Somewhere over here. Isn't it? So, I think over here, I'll get 0.80, 1.25, 1, and this is 1.5. So, in between, we'll get 1.25. Am I clear? Just look carefully. Now, 0.6 second, 1.8. 1.8 must be over here somewhere. 1.8. See, I'm doing it approx. Now, if you join this point, if you look carefully, we get a curved line. We don't get a straight line, which means this is a non-uniform motion. What they have asked? Yeah, the motion is uniform or non-uniform. Since we didn't get a straight line, we get a curved line. So it's a non-uniform motion. Clear? Now let us look at the next sum. Now look at number 8. This figure shows the velocity time graph. This is velocity in meter per second. This is time in second. For the motion for body, use it to find the displacement of the body at t equals to 1. So at t equals to 1 second, you need to find the displacement. Then at t equals to 2 second, we need to find the displacement. At 3 second and at 4 second, we need to find the displacement, of course, in meter, and this is in second. Then draw the displacement time graph for it. Now, first thing, look over here. How do you find the displacement using the velocity time graph? We have done by finding the area between the curve or the line, you can say sketch, whatever, the graph, and the x-axis or the time axis. Look carefully. After 1 second, so this is your sketch. If you find the area of this portion, this is a right angle triangle. If you look carefully, you'll get the displacement. So 1 second, the displacement is half into base into height. This is 1 again. That is 1 by 2. That is 0.5 meter. This is 0.5 meter. After 2 seconds, see, again, then this is your figure. 2 seconds, the displacement is half into base is 2 into height is 2. Area we find, that's 2 meter. Then at the end of 3 seconds, see, it's the bigger triangle. So 3 seconds, displacement will be half into base is 3 and height is how much? Height is also 3. That's 9 by 2. That's 4.5 meter. 4.5 meter. And after 4 seconds, again displacement will be half into base is 4 and height is 4. If you look at the diagram carefully, that's 8 meter. So after 1 second, the displacement is 0.5 meter. After 2, it's 2 meter. After 3 seconds, it's 4.5 meter. And after 4 seconds, it's 8 meter. Now they told us, draw the displacement time graph for it. Now the displacement time graph, I'll draw it over here. Just look carefully. Displacement time graph. This is displacement in meter. This is time in second. 1, 2, 3, 4 second. 1, 2, 3, 4 second. This is suppose 2, 4, 6, 8. 2, 4, 6, 8. Now carefully plot the point. 1 second, 0.5 meter. This is 1. Somewhere over here. This is a 0.5 meter. 2, it's 2. Somewhere over here. Look carefully. After 3, it's 4.5. 4, 5 is over here. 4.5 is over here. So, after 3 seconds, somewhere over here. After 4, it's 8. So you getting a curved line. Look over here. Isn't it? This is your displacement time graph from this velocity time graph. We got this table, and from here you can construct this. I think easy. Clear? Now let us look at the next one. Now look at number 9. Figure shows a velocity time graph for a car starting from rest. The graph has 3 parts: A, B, B, C and C, D. Number 1. State how is the distance traveled in any part determined from this graph. We know by finding the area between the sketch and the x-axis or the time axis. We find the area and that is equal to the distance. By finding the area between the sketch and x-axis, or you can say time axis, both means the same thing. Okay. Number 2. Compare the distance traveled in part BC with the distance traveled in the part AB. First look. Distance traveled in the part BC. Distance traveled in the part BC. Now area of BC, include area of this portion actually. This looks like a rectangle. BC, suppose this is EF I'm talking about. You know, under this line you have this area. So what will be the area? Area will be length into breadth. Suppose this is your length, which is V0, and breadth is what? 2t minus t, which is t. So V0t is the distance traveled during this part BC. Now distance for the part AB. This is the area, which is half into base into height, which is half into base is what? T, and height is V0 again. So that's V0t by 2. If you divide the two, distance traveled by BC and distance traveled in the part AB. V0t divided by V0t by 2. 2 goes up, that's 2 by 1, which is 2:1. So the ratio will be 2:1. They said compare the distance traveled in the part BC with the distance traveled in the part AB. That's 2:1. Done. We found the area. For the BC part, the area will be length into breadth. For the AB part, the area is half into base into height. Which part of the graph shows motion with uniform velocity? This is uniform velocity, because see, the velocity is not changing. It's V0 only. This is uniform velocity. The part BC. Acceleration, of course, AB, the velocity increases. This is acceleration. And retardation, the velocity decreases. This is your retardation part. This was number 3. Number 4, the last part. Is the magnitude of acceleration higher or lower than the retardation? Now if you look carefully, the greater the slope, the greater will be the value. In case of AB, the slope is less as compared to CD. The steepness, slope is what? The steepness. If you see, AB is less steep as compared to CD. So retardation will be more. Retardation is more as compared to acceleration, isn't it? Give a reason. I've told you. Okay, the slope over here is more as compared to slope over here. Now what they said? Compare the magnitude of acceleration and retardation magnitude. Now for AB, for the part AB, your acceleration will be change in velocity, change in y coordinate, which is v0 minus 0, by change in time, which is t minus 0 is t, so v0 by t. This is your acceleration. Retardation when we're talking about part CD. For the part for CD, your acceleration, suppose we are finding 0 minus v0. See, final, initial was v0. Change in time. Change in time is what? 2.5t minus 2t, which means 0.5t, which is minus v0 by 0.5t. So your retardation is negative of acceleration, which is v0 by 0.5t. Divide the two. So acceleration is to retardation, you'll get v0 by t divided by v0 by 0.5t. That is v0 by t multiplied by 0.5t by v0. So that's 0.5, which means half. So the ratio is 1:2. Compare the magnitude of acceleration and retardation is 1:2. Okay. Now let us look at the next sum. Now look at number 10. The velocity time graph of a moving body is given below, given here. Find number 1. The acceleration in the part AB. Very easy. Acceleration in the part AB. The slope, which is change in y coordinate, which is 30 minus 0, by change in x coordinate, or velocity by time, 4 minus 0. That's 30 by 4. That's 15 by 2. That's 7.5 meter per second square. Then in the part BC, acceleration in the part BC. Now for this part, the body is moving with uniform velocity. The velocity is not changing, which means the acceleration will be 0 meter per second square. Done. Then the acceleration in the part CD. For the part CD, look over here, CD. The final velocity is 0. The velocity is decreasing, is retardation. Initial velocity is 30. So 0 minus 30 by 10 minus 8. That's minus 30 by 2. That's minus 15 meter per second square. The negative sign indicates retardation. Am I clear? Now, displacement in each part AB, BC and CD. We know how to calculate displacement. Displacement means the area. Look over here. First, part AB. Displacement in the part AB. That's half into base into height. That's half into base is 4 and height is 30. So that's 60 meter. That's the displacement. Half into base into height. Then displacement in the part BC. That's a rectangle. Length into breadth. That's length is how much? 30. And breadth is how much? This is 8 minus 4. 4. That's 120 meter. Then displacement in the part CD. This one. Again, half into base into height. Half into base into height. That's half into base is 2. And height is 30. Base is this, 10 minus 8. That's meter. Yeah. For AB is 60 meter, for BC is 120, and for CD is 30 meter. Then they ask the total displacement. Now the total displacement, we'll just add it, which is 60 plus 120 plus 30, which is how much? 210 meter. That's the total displacement of the body. Done. Very easy. Finding the area, you get the displacement. Remember that. Finding the slope, you get the acceleration. Done. Now let us look at the next sum. Now look at number 11. A ball moves on a smooth flow in a straight line with a uniform velocity 10 meter per second for 6 seconds. At t equals to 6 seconds, the ball hits the wall and comes back along the same line to the starting point with same speed. Draw the velocity time graph and use it to find the total distance traveled by the ball and its displacement. See, we've done a graph like this. You can click on the I button and see the video, the graph, all the graph I've explained. If you see that video now, it will be quite clear. Look over here. This is your velocity. Now, velocity can be positive as well as negative depending on the direction. This is your time. Okay, the x-axis in second. Now, this is suppose 10 meter per second. This is suppose minus 10 meter per second. This indicates towards the starting point. This indicates away. Suppose this is 6 seconds. Okay. I'll just read one more time. And wait. And comes back along the same line to the starting point with the same speed. Comes back. Okay. With the same speed. Which means after 12 seconds. It hits the wall after 6 seconds at 10 meter per second, so we get something like this, isn't it? But at 6 seconds it hits the wall and returns back, which means speed will be now minus 10, isn't it? I'll just at t equals to 6 seconds, the ball hits the wall and comes back along the same line to the starting point with the same speed. Which means now after 12 seconds, it will come to its initial point. This represents the body is moving towards the initial point. This represents it is away. Now what they have asked. Just look over here. Since the speed was same, so to hit the wall it takes 6 seconds. So return back, again it will take 6 seconds. The speed does not change, they have told. Draw the velocity time graph. This is the velocity time graph, and use it to find the total distance traveled with the ball and its displacement. See, when you talk about distance traveled, area of this will be length into breadth, which is 60 meter. Because area gives you, area is what? This is 6 seconds. This is 10 meter per second. So 6 seconds into 10 meter per second, velocity into time gives you distance or displacement, This is distance. A1. Over here, A2. Again, this is 6. This is 10. If somebody does minus 10, we are taking the displacement there. So the distance is 10 meter. Just finding the distance first, okay? If you talk about displacement in this case, displacement will be minus 60 meter. Okay? Now the total distance. If you talk about the total distance, it will be 60 plus 60, that's 120 meter. But if you talk about total displacement or the displacement of the body, 60 and minus 60 over here along with the sign. See, displacement above the x-axis, we have done it, is positive. Displacement below the x-axis is negative, so that's 0 meter. So the body is at its initial position. Done. Now let us look at the next sum. Now look at number 12. This is the last sum, I think. This figure shows the velocity time graph of the particle moving in a straight line. State the nature of the motion of the particle, velocity time. See, in this part, from 0 to 4 second, from 0 to 4 second, it is accelerated motion, and from 4 to 6 second, there's a retardation, isn't it? Retardation. Done. So from 0 to 4 second is accelerated motion, from 4 to 6 second is deaccelerated or retarded motion. Find the displacement of the particle at t equals to 6 second. The displacement. Very easy. First part. From 0 to 4 or the entire, from 0 to 6. It's a triangle. Area will be what? Half into base into height. Thus half into base is what? 6. Height is what? 2. That's 6 meter. Of course, time is in second. This is meter per second. So meter per second into second gives you 6 meter. That's your displacement. This is 6 meter. Positive because it is above the x-axis. Now, number 3. Does the particle change its direction of motion? No. It does not change. Accelerated, deaccelerated. The graph does not go down below the x-axis. Then they have asked, so this answer will be no. Number 4. Compare the distance traveled by the particle from 0 to 4 and 4 to 6. So in the first C, over here, distance for 0 to 4 second, half into base, which is 4, into height, which is 2. So that's 4 meter. And distance from 4 to 6, that's again half into base, which is 6 minus 4 is 2, into height, which is again 2. We are finding the area, that's 2 meter. Okay, what they've asked, compare the distance. So this is suppose D1 and this is D2. So D1 is to D2, it will be 4 is to 2, that's 2 is to 1. That's the comparison. Okay, now number 5, they've asked find the acceleration from 0 to 4 second and retardation from 4 to 6 second. So acceleration from 0 to 4 second, slope of the line, and slope is what? Change in y coordinate by change in x coordinate. That's 2 by 4, that's 0.5 meter per second square. And for this part, acceleration from 4 to 6, change in y coordinate, this is 0 minus 2, by changing x coordinate, which is 6 minus 4, this is minus 2 by 2, that's minus 1 meter per second square. Negative sign indicates retardation. Acceleration is minus 1 meter per second square. Therefore, retardation will be 1 meter per second square. Am I clear? Yes, they have asked that only. So, this was the last sum. Keep it till here for this video. In the next video, we'll look at the next part. Till then, take care and be safe. And if you like the video, do subscribe.